Hello everyone. Today we will discuss some more examples to write a algorithm. Okay. So the first example is to find the largest of three numbers. In the last video we have discussed the largest of two numbers. Now if there are three numbers, then how to print the largest among them, right? So again the name of the algorithm is largest of three numbers. So what are the input variables here? A, B, C. Why I have taken A, B, C? Because they have given three numbers. So you have to read three numbers. Read A, B, C. Okay. And in step 2, compare A and B. So in comparison, here you have to compare all the three variables A, B and C. If you are printing A is a larger or A is a biggest, then A must be satisfied with B and A must be satisfied with the C. Okay, it has to satisfy with both the variables, then only you can print A is larger. So then what is the condition? If A is greater than B, if the condition is satisfying, if the condition is correct, then go to step 4. So in step 4, it comparing A and C. Here in the step 2, A is greater than B, the condition is correct, the condition is satisfying. Then it compare with the C, whether A is also greater than C or what. So the condition is if A is greater than C, then print A is largest. So in the both the condition A is greater than B and A is greater than C, then it print A is largest. Okay. In step 2, if in first step 2, if the condition is wrong, if the condition is not satisfying, then it will not go to step 4. So simply it moves to step 3, that is if B is greater than C, means it compare B with C. If B is greater than C, then it print B is largest, else C is largest. Either it print B is largest or C is largest and go to step 5. So go to step 5 means stop. Okay. So if you take any variable to print, that is A, B, C. So if you are printing A is larger, then A must be satisfied with B and C. If you are printing B is larger, then B should be satisfied with A and C. If you are printing C is larger, then it has to satisfy with A and B. Okay, then only you can print A is larger, B is larger or C is larger. Okay, so here either you can print first statement, second statement or 3 statement. Okay, so this is the algorithm to find the largest of 3 numbers. So next we see the analysis of largest of 3 numbers. So here read the input values, that is A, B, C. So I have taken A is equal to 10, B is equal to 5, C is equal to 2. Now compare A and B. So what is A? 10 and what is B? 5. So here 10 is greater than 5. Yes, the condition is satisfying. Then it move to step 4. So in step 4, compare A and C. That is A value is 10 and C value is 2. So here also 10 is greater than 2. Then it print A is larger and stop. We will take another example, that is assume A is equal to 10, B is equal to 50 and C is equal to 2. Now the first condition is not satisfied, that is 10 is not larger than 50. Then it simply move to the next statement, that is B is compared with the C. So here the value of B is 50 and C is 2. So B is larger than C, yes, then it print B is larger, because in both the cases B is larger, else it would print C is largest and stop the algorithm. Okay. So read this analysis correctly, then you will understand how the problem is executing, how the problem is tracing or analyzing. Okay. So try to understand the problem. So this is the algorithm of finding largest of 3 numbers. Next, to find the GCD of 2 numbers. So to find the GCD of 2 numbers, first you have to know, or you should know, what is GCD. So GCD means GCD of 2 integer is the largest integer that can exactly divide both numbers. Okay, so GCD means what? greatest common divisor. If you take any two number, so whatever the number you take, that number must be divide both number exactly, then that number is a GCD. If the example is 20 and 28 are the two numbers, two integer numbers, so if you divide these two number by any number, so that number will be the GCD. Here 4 is the GCD of a 20 and a 28. Okay. So in this algorithm name is to find the GCD of two numbers. So what you have to read? A and B, that is input value. The condition is if A is greater than B, then N is equal to A and D is equal to B. So whatever the number you have taken, whatever the number you read, so according to those numbers the condition must be satisfied. So A is greater than B. If the condition is true, then it execute the following statements, that is N is equal to A and D is equal to B. Now you may ask, what is N and what is D? So N means a numerator and D means a denominator. So numerator means it is the top of the fraction, the number which is appear on the top of the fraction, and D means a denominator, it is the bottom of the fraction, or it represents the number bottom of the fraction. Okay. So it simply assign the value of A to numerator and the value of B to denominator. Else, if A is not greater than B, if A is not greater than B, then it executes the second statement, that is N is equal to B and D is equal to A. So it means, so it should satisfy the first condition, means always the first number must be greater than second number, or the numerator must be greater than denominator. Yes. Then end if means here the statement is a stop. Then in step 3, R is equal to N mod D. So R means here you have to find the remainder of two numbers, remainder of a numerator and a denominator. So here to find the remainder, here we are using the symbol percent. So percent symbol is used to find the remainder. So R is equal to N mod D. So whatever the remainder you get, that will be assigned to R. In step 4, while R is not equal to 0, to print the GCD, so the condition always must be satisfied as R should not be equal to 0. R should not be equal to 0. Okay, if R is equal to 0, then it stop. If R means remainder, if a remainder is equal to 0, then it stops. If a remainder is not equal to 0, then it continuously execute or repeat the same process. Okay. If the condition is true, then step 5, it executes step 5. So in step 5, what it is executing? N is equal to D, D is equal to R is equal to N mod D. So these three steps are continuously or repeatedly processing until you get R is equal to 0. Okay. So it assign N is equal to D, D is equal to R is equal to N mod D. Again it go to while, whether R is equal to 0 or not. If R is not equal to 0, again same process. If R is equal to 0, then stop. Okay. Once it get R is equal to 0, then it comes out of that loop, that is while loop, and in step 6, GCD is equal to D, means whatever the value of D is finally you have got, that will be assigned to GCD and print GCD. Okay. So this is the simple example of a GCD to two numbers. Now we will see the analysis by taking one example. So here assume the value of A and B is 28 and 20. You can take any two numbers, 20 or 28 or any two numbers. Okay. So in the second step, compare A and B. So according to the condition, always numerator must be greater than denominator, or the first number should be greater than second number. So here A is greater than B. A means what? 28. 28 is greater than B. Yes. Then 28 is assigned to N and 20 is assigned to D. If A is not greater than B, if A is not greater than B, then what happens? N is equal to B and D is equal to A. Okay. So anyhow you have to assigning a and b value to numerator and denominator according to the condition. In step 3, so what we are calculating? R means n mod d. So what is the value of n? 28. What is the value of d? 20. So 28 divided by 20, the remainder is 8, means 20 ones are 20, quotient is 1 and the remainder is 8. So 20 ones are 20, so in 20 minus 20 is 8, so 8 is the remainder, so R is the remainder. So step 4, in this condition check whether R is equal to 0 in while. So here we are checking whether R is equal to 0 or not. So always the R should not be equal to 0. Okay, if R is equal to 0, then simply it stop the processing and print GCD. But in this R is equal to 8, means remainder is equal to 8, which is not equal to 0. 8 is not equal to 0. Yes, then it follow the or it process the following steps, that is n is equal to d. What is n? 20, and d is equal to r, means r is 8, that is assigned to d. After that it process r is equal to n mod t. N means 20 mod 8. So 20 divided by 8. So 8 2s are 16, means 2 is the quotient and the remainder is 4. Okay, after processing again it go to the while loop. So now again it check whether while r is equal to 0 or r is not equal to 0. So still r is not equal to 0, means 4 is not equal to 0. So again process the following steps. So n is equal to d, that is n is equal to 8, d is equal to r, that is r is equal to 4. So again next third step, r is equal to n mod d, that is 8 mod 4. So 8 divided by 4. So 4 2s are 8, 2 is the quotient and remainder is 0. So now the remainder is 0. Again go to step 5, then again it checks while r is equal to 0 or r is not equal to 0. So since r is equal to 0, then it will not go to or it will not execute the next steps. So simply it stop processing and execute. Okay, that is in step 6 GCD is equal to D. So what we have the value of D, that is a 4. So GCD is a 4. Then print GCD, that is in last step print. So GCD of 28 and 20, that is 4. So 20 is divided by 4, 28 is divided by 4. Okay, so both numbers should completely divided by the same number, that is a 4. Then only the GCD of 28 and 20 is 4. Okay, so this is analysis of the algorithm of finding GCD of two numbers. Okay, so trace the algorithm by taking any values, then you will understand the algorithm properly. So here also write the algorithm only, don't write the analysis. So only for your knowledge I have given the analysis. Okay, means how the algorithm is executes. So don't write the analysis, just you try to understand, but only write the algorithm in your fair book. Okay, so thank you.